the operation of the research vessels. We have reviewed today the half of the path of the scientific research process. We started with looking at the generation of the question. How do we formulate the scientific questions that oceanographers will be expected to address in the next 10, 20, 30 years? We then proceeded to looking at the instruments that will be necessary to conduct the measurements and collect the empirical evidence in support of the research projects. We then just looked with Jim Bellingham and his panel at the robotic systems and their evolution. And now I would like to introduce to our wonderful attendees of the symposium who are now filling our room and are almost all here.
Maybe I'll fill it in for just a minute here.
Yeah.
There are a lot of people saying, well, you know, we wish the panel go a little longer. We have so many questions and so many opinions and things they want to discuss. We really hope the discussion will continue and they don't stop here. So we're going to try to put up a forum on our website. And so people, please do log in your questions and email us all your questions and what you'd like to discuss. And then we'll ask our moderator to work with us to continue the discussion.
There are so many questions. It is actually very encouraging. It's wonderful to see the level of interest and level of excitement and all the wonderful and pertinent and very acute and interesting questions that we're receiving. We would encourage all of you, if you haven't had a chance to make a quick comment or ask a brief question during this live session, please do post those questions on the media site, on our communications, on our website that provides the webcast and also feedback to the panels. And we will then assemble all those remarks and comments, and we will create a Google group dedicated to the symposium. We will link it from the webpage where you can see the agenda right now. And we would like for these discussions to continue. We would like for these discussions to inform not just ourselves, but many of our collaborators. And we would like for the friendships and for new connections that have been established during these meetings today and tomorrow to continue and to help us drive the oceanography and technology development for oceanography in the future. Now it looks like everybody's here, and I would like to introduce our last panel for today. We will now be looking at the ways that the roles of the oceanographic research vessels are evolving over time, and our very good friend and colleague from NOAA, David McKinnie, very kindly agreed to help us organize and lead this panel. David, please feel free to present your panel participants.
Okay, great. Thanks very much, Victor. And just one logistical question. My timekeeper is right there. Got it. Okay, thank you. It looks like a small bomb or something. So, yeah. Okay. So, first of all, thanks to everyone for coming back, given that we are in Hawaii and the beach is right there. There are several bad things about being the last panel of a day, starting with the fact that I think almost all of us are pretty much jet-lagged right now. And it is the end of the day. But a very good thing about being the last panel is we've had the benefit as a panel of seeing and hearing the conversations that have come before. And as Victor mentioned, these are carefully sequenced so that they build on each other. Ships play a very important role, but not the only role. And it starts with the science requirements, the science drivers, and flows through the different topics that we've just discussed. So it's really a luxury for us to be able to think about those things and to incorporate them into our remarks. So I'd like to start with thanks to the Schmidt Ocean Institute for organizing this. Many of you participated in an event in July, Ocean Exploration 2020, a national forum that NOAA co-hosted with the Aquarium of the Pacific, which also talked about some of these questions. But we viewed this symposium as a very important follow-on to get into deeper detail on the topics that were raised about in July for what constitutes an effective national program of ocean exploration, a program of exploration that includes all the stakeholders, whether it's James Cameron or David Lang and Eric Stackpole, the Open ROV guys, or HUI or NOAA or NSF or whomever, all the stakeholders in ocean exploration. So we're excited to be here. Now ships are interesting. In some ways, they're kind of simple, and in other ways, they're incredibly complex. And they also can be so emotionally charged as to border into a religious topic. So what we've done here is assembled an interfaith council to talk about the ships. So I'll start at the far end. Admiral David Score is in charge of the NOAA fleet. So that represents, he's representing not only NOAA, but kind of the federal perspective of vessel operators. And then next we've got Bruce Appelgate, who's with Scripps, and he's representing the perspective of an institution that operates a vessel, both for UNOLS and otherwise. Next we have Peter Ortner, who is, you're the chairman of the UNOLS? Okay, so obviously pretty important to most of us in one way or another. And then finally, and certainly not least, Marc Nokin from IFREMER, representing an international perspective, and also, as it turns out, a close collaborator of many of us in this room. We'd hope to have Ridwan Djamaluddin from the Agency for the Assessment and Application of Technology in Indonesia to represent kind of a developing world perspective with still a quite capable fleet. But unfortunately, he wasn't able to come, so we'll try and work in some perspectives based on my experience in Indonesia to help provide as complete a picture as we can on this question of where are ships going, how will they evolve in the future, and what does it all mean anyway. So I'd like to start with a couple of observations, and then we have a kind of a rhetorical statement, and then 7 topics that we're going to try and address with you. And then I'm sure Victor is going to give me back a few minutes that he took from me so that we can have a complete discussion with you and get as many questions on the table as possible. So you might expect that one of the first things that we did and I did was to review the considerable number of reports that deal with the question of the fleet, the research fleet. And it was interesting that most of them said some variation of the following things: that the size of the fleet is declining, that the cost of operating the fleet is increasing, planning horizon is long, very long, too long, that technology is changing, that the mix of the fleet may not be right, but nevertheless we need more vessels. And kind of a linear projection out of where we are today over the next 10 or 15 years. And that's not quite fair, but it's kind of generally what these reports tend to say. But it really begs a kind of important question, which I think we're here to address, and that is, you know, given that ships are essentially a mechanism for delivering something or picking up something, delivering a buoy or picking up a sample or an observation, and there are alternatives out there, you know, the rhetorical question is, what do we need ships for anyway? You know, what are the requirements now? What are the requirements in 10 or 15 years? How do we get there, and how do we plan for the future as best we can? And so those are kind of intriguing questions. And I'd like to give you an example that's very fresh and very current, and also directly relates to Eric and Wendy's other foundation, one of the other foundations, the Marine Science and Technology Foundation, to give you an example of how this could play out. Now, Richard Jenkins is here somewhere, back of the room. He's got a little project called Sail Drone, and it's a kind of looks like a scaled-down America's Cup catamaran in a way. And currently, it's 190 miles offshore of where we are right now. Okay, now, the sail drone can be programmed to sail somewhere, park on a station, do a little racetrack for a year, collect data, and come back. Okay, now combined with a subsurface mooring, it's entirely possible, we don't know because we haven't tested it, we'd like to, that perhaps a sail drone, which doesn't cost that much, could replace a tow mooring in the equatorial Pacific and deal with a whole host of issues, not least of which is removing the requirement for a very large ship to go get it once a year and clean it up and put it back in the water. So that's an example of how technology could possibly change the way we think about ships and the kind of mindset I think we have to have as we deal with this thorny and interesting religious question. So first slide, please. Okay. So here's the basic question. You know, what do we need them for, and what does it mean for the mix of the fleet in the future? It would be kind of unfortunate, I think, to assume that we've got a linear trajectory to worry about, and that in 15 years we would like to have more efficient ships, kind of basically the same kinds of ships, and perhaps more or less of them. The question is, of course, much more complicated than that. And as we thought about it, and as we referred back to the surveys that many of you, thankfully, filled out and contributed to, we realized there were 7 themes that might help. Next slide, please. So these are those themes, and most of them were picked, the comments you made and then we added to it, of course, pretty much fall into these different categories. And so to start our discussion with our panel, we'd like to refer to these themes. And what we'll do is I'll ask one of our panelists to start the discussion, and the rest of the panel will pick it up. And then please take notes for your question as we move your questions as we move through these topics. So, paradigms of operation means do we have a traditional PI-driven process? Do we have possibly a telepresence model? What about survey operations where you're just mowing the lawn to get something or another, whether it's bathymetry or PCO2 measurements or whatever? So that's paradigms of operations. And modes of operations, and I'm putting them together because Peter is first up. Modes of operation are what ships are doing when they're doing different things. So many of you have already commented that it's borderline criminal to drive a ship somewhere and not collect data. Marcia made that point eloquently about the importance of Doc Ewing having no idea why it was going to be important in the long term completely, but knew it was important, and so it was done. So transit, what are the kinds of things that need to be done when a particular area is identified and it's prosecuted with a variety of instruments? And then finally, what about this question of processes? How do you explore or understand something like ocean acidification? So Peter.
So it's a little hard to separate all these things, and I apologize if I trample into another topic, and I think we'll all end up doing that.
Well, the last panel talked about ships, and I was going to raise my hand, but.
But in terms of paradigms of operation, what we're thinking about there is in our fleet, we tend to have the UNOLS fleet. This is projects are either they're PI-driven projects. We call that the conventional approach, the model. And they could be big teams of PIs and big programs instead of projects that many of us have made our whole career around. But it's still, basically a PI-driven thing, and the people involved are out there doing the work. But it's a totally different paradigm of operation now in our new developing world with telepresence and the ability to communicate. In that, and we've had some lovely recent examples. I'll let Bruce maybe go into this in greater detail. Because I think they did one of them, was specifically where PIs, people involved directly themselves in the science operation, didn't have to be aboard. Okay, some were. It wasn't entirely technicians, but a number of people who contributed, allowed things to modify through time, adaptively sampled, to use Cabell's term, which I love, weren't there. Okay. And then there's the example you just said. There's a survey mode. Now, there's the example of taking the information on your way to and from a place or in the midst of any one of these other things. But there's also the routine surveying, and I'm going to let Dave talk more about that because that's a lot of what the NOAA ships are doing is survey operations. But I'll point out, going backwards in terms of the exploration and research concept, that we're kind of separated there. In my view, they're not necessarily that different. Part of exploration is surveying. You drive around, you use the multi-beam, you're exploring to determine where you want to do the research in part. So there's an exploration aspect of that. You might go to that spot, you might actually use an HOV, who knows what you will use, but they're not so clear. It's not so clear what part of it is survey and what part of it is research, what part of it is exploration. We discussed here the transit to it. It's definitely the rule in all of the fleets that the message is well understood. Anybody who can piggyback in a useful way between places is more than welcome. They are given the royal treatment to come aboard and do that. And as well they should, because it's more bang for the buck, and you heard some wonderful examples from Marcia. From my perspective, and then there's sort of two things that were distinguished here in modes of operation when we talked about in advance. There's a mode of operation where you're studying a process, and the process might not be geographically specific. For example, you might be interested in a global process like ocean acidification. Well, your actual mode of operation could be measuring pH as you steam all over Hellengon, or it could have been actually looking at the details of all of the aspects of the carbon biogeochemistry in a specific environment that you deem of interest and may be extrapolatable. And last, there's this issue that I touched on before with exploration. In terms of a geographic area, you had the exploratory phase that you even determined that area with. You might have been partly accomplished during a survey, but your objective really is to nail down the attributes of that for some purpose or another. I notice we don't really have this exactly in here, so I'll just make one last comment before giving Dave the microphone back here, is the answer to why you have ships at all, I think, is in part a very clear one, in at least part of the equation. The answer is the most valuable science is the serendipitous science. If we were really smart enough to do everything automatically, and assuming that one of the guys in this room, not me, could invent something that would actually do exactly what a human could do, you'd still have to know it really very well in advance and have that communications capability and flexibility that there's a physical barrier to with something that's underwater, to be able to do some of the serendipitous kinds of experiments, discoveries that really are the things that end up in nature or science. It's no one ever, what my mentor, Doc Edgerton, said, and I quote him forever, is if an experiment ever comes out exactly the way you predicted, you didn't learn a damn thing. And I think that's true.
Okay. Great. So Dave, I'd like to ask you to comment on that with the thought of, what might this look like in 10 or 15 years? What will be different?
I would say, just building off a little bit of what Peter said, is that ships are really just enablers of the observational requirements. What does the science community need to do? And if you look at, we've been sailing ships for at least a couple thousand years more. The hull forms haven't changed all that much. And if you look at the new ships being built now, they kind of converge on a common hull. But what do they need to do to enable the observational requirements? And you look at the Falkler, great ship, but it was built in 1981. But what technology did they put on it? So do I think ships are going to look radically different? You tell me, what do you need to do? What are the requirements? And with our longer planning horizons across whatever community we're in, we have to really look towards adaptability, flexibility, how these ships can be nimble enough to, whatever you guys dream up, whatever those needs are, that these ships can be adapted and meet those requirements, and how they can integrate the technology that's coming out to be sort of force multipliers. How can you get a bigger bang for the buck for being out there, serve more requirements per day, per hour, what have you? And I think a lot of the discussion that we heard today is going to make that a reality. It's our challenge, our job really, to make sure we have reliable, capable platforms that can pivot as they need to be over the next 10 years. So the take home is I don't see ships looking that different. I think the people on them are going to probably have to be different, and I think the technology certainly will need to be different and will be different.
Great. And Bruce, a quick comment before we move to the next topic?
Sure. It's thinking about the kinds of ships we'll need in the future. You can comment on the hardware, but also I think what I'd like to comment on is how we use the ships in terms of, if you look at the UNOLS paradigm for scheduling, the people that set that up were visionaries, I think, in figuring out how to work together to operate ships the most efficient way possible. And when expeditionary oceanography started with ships going, I think of the Horizon expedition in the 50s at Scripps, basically a circum-Pacific expedition where a bunch of people got on board and went and these Renaissance people went on board and did a whole bunch of things. But you can't operate ships that way anymore because you just drive around wasting fuel. So the UNOLS approach has been to always collect data from point to point as best we can. And currently, that's still very much a PI-driven process, mediated by the scheduling process that goes on annually. So that it's the responsibility of the agencies and the schedulers to figure out where the ships are going to go. But You know, in the future, as you know, if we continue to be resource limited and we need to work in even more remote places, the Southern Ocean, Indian Ocean, for instance, we might think of better ways to more efficiently use our assets in those remote areas where you might plan even farther in advance, where you have groups of scientists who are prepared to write proposals to go in that part of the world, and then you know, maybe with a 2 or 3 year planning lead time, go out and do it and change the paradigm just a little bit that way.
Yeah, that's an important point, and I would add to that, given some experience we've had with international partnerships, that as you get to these remote areas, you do need international partners, and that adds non-science requirements for lead time. 2 years perhaps to develop the climate in which you can actually get a research permit and get a ship cleared into particular countries. Not that we don't have personal experience with that. So that's an important factor and an observation I think that Ridwan would have made, because in addition to the science driver and the kind of legal environment requirement that you have to meet and the permits, then you've also often got a capacity building need that's related to science, but it's not really science. What our partners often want internationally is a relationship where their scientists can work with our scientists, and that's quite different than the partnership that you might form among your colleagues in this room. So,
I would, if I could just add, I think that's a really good point, that this is a global issue. It's not a U.S. issue. The last 3 days before I came here, I was in St. John's with the URSO group, International Research Ship Operators, talking about these very things. How do we leverage each other's capabilities, assets, be smarter about how we do this? Everybody's dealing with the same issues across research fleets, internationally. So it's important to work together and to be looking at those longer planning horizons.
That's right, great, thanks. Now, speaking of our international partners and friends, and also I think this question of technology, I think Dave's absolutely right. The science drivers should determine what the fleet looks like and what the fleet does. But it looks like there may be some barriers we're coming up against in terms of efficiency and naval architecture in general. So I'd like to ask Marc to introduce the topic of platform technology and share some thoughts that we can learn from our friends at IFREMER.
Yeah, thank you, David. I am a general engineer, so I am going to discuss about the platform technology on a general design of ships. Of course, there is many things to say, but when you can, to imagine what will be the design of a ship in the future, I think that this is very interesting to have a look in the past, in fact. And when you compare two ships 20 years ago and nowadays, so the ships have significantly progressed. A ship today is about 30% more displacement for the same length as a ship 20 years before. For example, a James Cook is 4,500 tons compared to the Atalante that was built in 1985, that was 3,500 tons. And so the volume has significantly changed. And what is the reason? This is because the beam has changed and has increased. 20 years ago, for 85 ships, we have a beam of something like 15 meters. Now this is 18 to 19 meters. And this can explain, of course. This is a scientific push. When we design a ship, we start from the stern working deck. And this is designing the beam of the ship. And now we have more and more underwater vehicles, moorings, bottom station, and so on to deploy. And this is because the technology has become to maturity, in fact. First ROV on board ships, this was in the 2000 approximately. So this is not so far away. Sorry, but I apologize for my very poor English.
Our French is much worse.
And this is the first point. The second point is that we have pluridisciplinary scientists on board. And every scientist wants to go on board with his own underwater vehicles, an AUV, deep tow, ROV, and so on. So we have a stern working deck completely full with many, many, many equipments. And to deploy them, we need space. And then we have a big stern working deck. Once you have a large beam with a given length, this is not necessary to do longer ship. okay, because you have volume, and so you have much more space to make laboratories, workshops, and so on. So we arrive to the fact that, and there is also something that is incredible, is that the block coefficient of a ship, this is the witness of the fatness of the ship, has increased in 20 years from 0.5 to 0.6, whatever the numbers. It has been increased significantly. This is the fatness of the ship. That means that the ship today is much more cubic than before. And so the slender ratio has completely decreased. This is like a cube, in fact. So we tend to a cube. I hope we will never arrive to a cube. So this is the point. And the point is that we have very high capacity ships, big capacity. We can deploy vehicles, we have labs, workshop. This is such kind of factory, in fact. But we cannot, so the question is, can we continue like that in the next decade or in the future? And I think that we have arrived to an asymptote, in fact, and maybe we are over the asymptote. And why? Because with a ship today, the power installed on the ship has doubled or trebled. 20 years ago, this was 2,500 kilowatts for a 85 meters long ship. Now this is 5,000. 5,000. And so we arrived to the point that very good capacity ship, but costly ship and not green ship. And you have to know that the impact of the ship on the environment is 80% due to the fuel consumption. So can we continue to make ships like that? And also because the fuel is expensive. So this is expensive ship and not green ship. And I think that in the future, we arrive to this asymptote and we are going to, and we must conceive new ships that are capable to do the same job, but not with the same box.
Yeah, thank you very much. And I think it is a very key point, the kind of practical limitations that we're running up against of shoving a cube through the water and the energy cost, but it also is a different flavor of the big ship versus little ship question, which I'm sure our panel will have some things to say. So Peter, please.
Well, I also wanted to comment, for the people in the room who aren't ship people, so ship enmeshed as some of us, the cost, I think, what was he said, in a decade, we've gone up a factor of 4 or 5.
400%.
Yeah, 400% in the fuel cost. So, we looked at our fleet over an 8-year period. The federally funded fleet went from paying 11% of the annual cost of ships up to, I think it's like 23% now, is just the cost of the fuel. Okay. Now, I would point out that UNOLS is very interested, and I encourage people to look at it, to the subject of having a greener fleet. We had a green workshop. We're going to have another one this winter. I'll let Bruce comment upon this in terms of fuel sources, but there's also been investigation specifically of hybrid engines and different modes of operation where you can save quite a bit of fuel. But if you're going to have an aspect ratio, sort of a shape of a ship like that, there are limits. Essentially, the only way you're going to save a lot of it is to get there a lot slower. Yes. Which, and I can tell you, having been a scientist who went to years on the ship, I'm always telling them to get to the next place I want to be as fast as I can. And now I've turned on the other side of the equation now. But there are these limits. There's also, right in our community, in the UNOLS community, almost two camps, a point of view, and I understand now, I talk more with my friend here, that the same thing really is true in Europe, between the people who are condensing and wanting us to go to the larger, more capable, squarer, fewer vessels, versus the people who say, you know what, for the same money as one more of those, we could have a half a dozen or more small, flexible vessels and distribute them around. And this, you guys might want to talk about it more, but the same exact dialogue is happening in both the US and in Europe about this point. It really depends what you want to do. I'll also point out, because I'm always looking for volunteers for UNOLS, for the Americans here, they don't have to be from a UNOLS member institution. We even have a subcommittee looking at the sail assist vehicles and what kinds, and surprisingly, one of the best things you can do is some forms of geophysics. Why is that? Because nothing's quieter than sailing.
Just because we have we have spoken about the big vessels, but I would like to say also something about the small vessels. For the big vessels, the revolution will be in the general design, okay, as I explained. For the small vessels, we will have to increase dramatically the capacities of the small vessels. And I take an example. So there is a scientific push, for example, to analyze the impact of the human beings on the ocean. And so this is concerning mainly the coastal areas. And to make investigation on coastal areas, this is, of course, with small ships. And to do this kind of work, so basically we need to have on board approximately the same tools on the big ships. That means ROV, AUVs, and so on. Not so big, but smaller one, but ROV and AUV underwater vehicles. And so we have completely to change the design of these ships that needs to be much more capable than today.
I think the previous panel had some very interesting observations about that, experiments with putting, fairly large underwater vehicles on fairly small ships, and be interesting to learn more about that. But I'd like to have Bruce or Dave comment. Would you like to add anything on this topic before we move to the next?
Just briefly, following up on the Green Fleet initiative within UNOLS, there's some really exciting developments going on with renewable diesel fuel now, so no net carbon emissions. We have the ability now to burn 100% renewable diesel, and it's something that we're about to start at Scripps next year for our smallest research vessel, Sproul. So if anybody's interested in that, I'd be happy to talk their ear off about what I think is a real exciting thing, because environmentally, we've always been at the forefront and cutting edge of doing the right thing in terms of how we dispose of our sewage and trash at sea. But the gorilla in the room is our burning of diesel and the emissions that causes. So I think this is pretty exciting.
It's certainly an area that's ripe for further development. I mean, the green ship requirement, it's not an option, it's a requirement, is something we all need to work on. Dave, do you want?
I would just, again, I would echo that we've been looking, that's one of your big cost drivers, as well as being the right thing to do. So we've been looking at how to drive that down. One of the big things for you scientists out there that go to sea, if the skipper wants to go a half a knot less, oftentimes that will save hundreds, if not 1,000 gallons of fuel a day, but you won't get to your station quite as fast.
So please be nice. Right. Okay, great. There's a related topic up here called platform reach, and some of the other panels mentioned it, and it's pretty exciting stuff. Research vessels no longer need to be confined to the instruments on board or even their submersibles, but you can envision motherships or plug-and-play platforms, kind of like mud boats with, and others have talked about this with instrument packages that you plug in and just swap in and out as you need to. So perhaps, Bruce, would you like to take that one? And,
sure. The last panel had some great insight into how ships can be used to deploy instruments and the neat kinds of instruments that are coming down the pike. And if I could predict what kinds of instruments we'd be deploying in 5 or 10 years, I'd be a really good investor, but I'm not. So I think one of the roles for research vessels is to be as flexible and adaptable so that when these new kinds of technologies do come about, we're able to support them and take them to sea. In terms of platform reach, I consider this to be there's two kinds of platform reach I think of. There's real and virtual reach, and the real reach of a research vessel is sort of the hardware that we've been talking about and being able to take things to sea. And there's a very healthy dialogue that is ongoing in the community is do we need ships and what do we need them for? And I think that sort of breaks down into different categories. There are some things that really only ships can do. If you have heavy lift operations, you need to collect a lot of water. If you need to mount an operation like we just finished in the Indian Ocean, something like Project Dynamo, where we had something like 8 vans on the ship that all did different things, and we had 40 scientists at sea, a very ambitious program. And it was science-driven, and you really needed an operation that big. Well, you know, that's a case for something that really only ships can do. And then there's sort of a category where, you know, ships or autonomous instruments can do things, but by doing them together, there's a synergy that really, it's a force multiplier idea. You can get a lot more done. And a good example of that is recently operating autonomous aerial vehicles on the equator, a project that we did where just by having a couple of drones up in the air collecting data, we could multiply our productivity by orders of magnitude by flying those off the ship. So that's a great example of how ships and instruments will continue to work well together. And then, of course, there's some things that, like gliders and drifters that we all know can do quite well, and you don't need ships at all. Although there have been plenty of cases where we need to go out and recover things, too, before they get into harm's way. So there's a need still for ships for that. But that's sort of the real side. I would also like to comment on sort of the virtual reach of ships. And this actually harkens back to something that Wendy mentioned at the start of the day today, where she challenged us all, and what have you heard good about the oceans lately? Well, one of the things that I think we're starting to do really well is the education. And you know, when I was going to school, we didn't learn about oceanography and plate tectonics and the marine sciences in elementary school, and that's something that my kids are learning now. And I think that's a direct result of a lot of hard work for decades now, people in this room and people like us. And just the happy story that I had was I was in the supermarket the other day, and in my city in California, Solana Beach, we no longer sell plastic bags. It's been a contentious issue locally, and it's an environmental reason. The city decided not to do that, and the lady with her daughter in front of me in line was complaining that it was just so inconvenient to not be able to have plastic bags. And her girl that was with her, who I would say is in 6th grade, said, well, Mom, the reason is because those bags end up in the oceans, and they do bad things. And the thing that made me really happy is the girl was able to cite the research cruise that was done on a UNOLS vessel that did this research. So I had to chime in there and support the girl. And, but that's a great example of the sort of virtual reach that our ships have. And I think that we need to continue to take advantage of these great ideas of how to use ships in a better way to continue this kind of outreach.
Great, thanks. Now, we are regrettably a little bit short on time, so I'd like to suggest that we maybe condense human factors. Some of our panelists have already talked about the human factors that, you know, as you have these more capable ships in the future, that requires a different kind of crew. They have training requirements. They need to be engaged as telepresence operations become more common. There needs to be a way to make sure there's a tight connection between the technicians on board the ship and the scientists who might be on shore, so that they work as a team and not at odds, which oddly enough as human beings that can happen. And then not insignificantly, and Peter mentioned it, the value of the education you get aboard a ship. Peter at lunch said that he would never clear a student of his for anything unless they'd spent time at sea. And I reminded him that things might change. But in any case, those are all human factor considerations that are pretty important as we think about the technology behind the fleet.
Dave,
It'll
be quick, but I'd also think about when you went to sea the first time, and there's a range of experience in this room, but you know, I got one fix if I was lucky when we were out of Loran range, you know, per day crossing the Gulf of Alaska. Now you have hundreds, if not thousands, of data points per second. We had radio operators for our weather, so just the mix of operators necessary to operate the ship is different. We've talked a lot in the previous panel about, you know, I keep saying you could train a monkey to drive a ship now, but they're not autonomous. You know, you'll never have an autonomous surface vehicle. You might have a remotely piloted vehicle, but that will have a tail somewhere that there's going to have to be a human in the system. So what does that human look like, and does it free up, you know, bodies on the ship? And as you take bodies off the ship, depending on what the volume of that ship is and the complexity of it, you also have to think about the safety of the personnel if you're going to put people out there. So it's a complicated subject, and it's all integrated. So it will be a challenge moving forward of the right mix of people. And I like to think about it as mission crews. You put the right people at the right place at the right time with the right capabilities, and you'll get a lot done.
Great, thanks. Now we have just a few minutes left to talk about the two easiest topics, fleet management and planning and funding. So that should just take maybe half of that, and then we'll get to the no, incredibly complicated topic, and many of you are painfully aware of the complexities of dealing with the issues. But I'd like to start with Dave and ask, from a federal perspective, we've got certain coordination mechanisms in place. How might those evolve, or what's lacking? What do we need in the future for coordination across all the stakeholders, not just the feds, but the academic institutions, private sector, foundations?
I think, one, a spirit of collaboration across the board. We're all facing the same issues. We've got similar but yet unique requirements, serving many mandates. As we look at transitioning to a new business model, potentially a new concept of operations, a new fleet mix with autonomous systems that are out there meeting the observational requirements, how do you balance that? How do you run your business while you're changing your business, and how do you forecast that? So while we're looking at like a 15-year planning horizon on the federal fleet, we have to recognize that we constantly have to readjust, reevaluate that at different key decision points. But that collaborative focus, the transparency, the willingness to be innovative in how we go about doing our work. And we've talked a lot at the UNOLS meetings, RVOC, as well as with the international community on some scheduling portal, some portal where everybody can see where ships will be looking in the future, and then how to create that forum that you can find synergies and again, force multipliers.
Great, Peter?
Yeah, we've made an effort in the last couple of years, as Dave's well aware, to try to really improve our integration, in particular with the NOAA fleet, and we're really looking to expand that, a deeper collaboration with NOAA, as well as a better collaboration with other partners, the Coast Guard, for example, who we do the science scheduling comes through our AICC too, our committee in charge of the science for their icebreaker, when the icebreaker they're permitted to do science on. But we really can do a lot better. We all of us involved in that dialogue know that it's really upon us, particularly in this environment in the U.S., with all the agency pressure and all the political environment, to really take this to the next level. I mean, we really cannot go on into the future with and survive any of the parts of the system with the inefficiencies that were historically true. And so I think I'm very optimistic that we'll improve on that front. It's been something I've been talking about for years. I mean, I had a 30-year career in NOAA before I was at the university, and this is like my second 6-year term in UNOLS. So, a lot of us are really concerned about this and committed to doing a lot better. We are faced with the problem of this 10 to 15-year horizon, so we're predicting the future, but I did learn from Dave that there was a recent example. Was it Japan? Who was it? Japan.
Yeah, they built a ship, well, literally built the ship in 9 months, but their whole window was 2 years, so pretty impressive.
Right, so that tells you that there's a political side to this. Maybe if we could do things a little better, we wouldn't have to have a 15-year window, and we'd be closer in our ship planning to the technology development.
Okay, great, thanks. And I'm going to give the last word to our colleague from IFREMER.
Yes, so the fleet management, so your system can be improved, of course, but I'm going to tell you that it can be worse also. We are in Europe 44 countries. We have 26 countries having a coastline, and among these 26 countries, we have 21 countries having a fleet. So we have to coordinate 21 fleets.
So we feel much better here in America. Yes. Okay. Great. Well, thank you all for these great comments. Of course, I wish we had more time, but we definitely want to hear from the audience and start to take questions. So first hand up I see in the salmon-colored peach shirt there.
Daniel Schwartz. I'm chair of the UNOLS Scientific Committee for Oceanographic Aircraft Research, but with a about a 26-year career of going to sea on research ships. I think it's important to elaborate on that concept of platform reach. About 230 years ago, when Captain Cook was coming to these islands for the first time, his sensor horizon around that ship represented what could be seen by a crew member up in the rigging. Now it's the 21st century, and the sensor horizon around a ship, even with electromagnetic sensors, isn't much more than that. So the idea of integrating, and that last panel gave us a lot of exciting ideas, of integrating these off-board platforms. Again, we're talking cost effectiveness to justify that 400% greater fuel cost in fielding a ship at sea. And the project that Bruce referred to, incredibly exciting. 2 autonomous air vehicles, 50, 60 miles away from the ship, one at 5 meters above the sea collecting air-sea interface data, another one up at 1,500 feet relaying real-time back to the ship, while the ship did the kind of things that a ship needs to do, heavy lifts and so on. So again, a real key to justifying these ships and finding new roles for them is increasing that platform reach through the adaptation of these new technologies, and happy for your comments on it.
Great. Before we turn over the panel, I think John Delaney did not pay me to say this, but the other aspect of that is full integration of all available data in that particular area. And at our Ocean Exploration Forum in Long Beach, this was a consensus outcome that exploration means incorporating all data sources from observatories to drifters to floats, whatever you have out there, to get a complete picture, as complete a picture as possible around your particular expedition or research voyage. So a very important point.
And I would just add to that, and this ties back to the standardization and interoperability so that those ships can receive that data, provide it to the PIs or the scientists so that they can make real-time decisions on where you might have an anomaly, an upwelling event, an eddy that might need to be explored, and they can incorporate that into their planning in a real-time basis. But the ship has to be capable of receiving that data and making it available to the PIs.
Absolutely. Bruce, go ahead.
Yeah, I was just going to mention one of the things that impressed me about the Falcor on our tour yesterday was their impressive off-ship communications capability, and it's something that the UNOLS fleet has had for years, the high SeaSnet capability, and we do a pretty good job. I think the Falcor really steps up the game another level with it's something like 6 megabit ship to shore and 2 megabit shore to ship. So that's great. And Marcia's comment earlier today about having these apps that we can use to access the sea. In order for that to work, we need to not only provide the data that fuels these apps so people on shore can access the apps, but more and more today, when our students come to sea, they come out with a smartphone, a tablet, a PC, and the first thing they do is they walk on board and they turn all of them on and expect all of them to work. And the data that we need to access on the ship, things like, where is the eddy right now? Where's the oceanographic front? You need to get that on the ship. And so having greater communications capabilities to and from the ship, I think is really key to extending the utility and reach of the vessels.
Yeah, excellent point. Next question.
Ian McDonald, Florida State University. Could you speak to the economics of owning a ship, building it, planning it from the keel up, versus leasing a ship? And I ask that in the context of working in the Gulf of Mexico, where we're very limited with the number of ships that we have. But ironically, there are vast numbers of ships available for charter, which could be fitted with A-frames, CTDs, etc.
How much time do you have, Ian? I think it depends on what, again, the requirements are. What capabilities do you need? How much time is it going to be used for? So I hate to. It almost sounds like I'm a lawyer, but I would say it depends. And it's a complex question, and again, that business case I think needs to be asked every time and explored very carefully before you make those investment decisions.
Well, I am a lawyer, so I can answer it. It actually really does depend. And the truth of the matter is there's also a number of cases where for specialized applications, there's no question, for example, cable laying some of the activities we're involved in with the OOI. I mean, you really want to do some of that stuff with people equipped for it. We're not going to take our general purpose adaptable vessel and do something so specialized with it, for sure. There's really no point. My experience, and I've done a lot of this, is that many of the commercial research capable or potentially research capable vessels, we've looked into them closely for the projects I've been involved with, and they really didn't quite cut it. For one thing, the one reason is the very simple one that on our vessels and on the NOAA vessels, you have, and the Falcor, we saw a wonderful example of it, you've got this crew that's really part of what you get with the vessel, and a really important part of what you get with the vessel to make it work. They're not just doing it for pay, and they're not just out there doing, that's just one of many things they do. This is their passion, and that makes all the difference in the world.
It does, yeah. Marc?
Yes, and also for the Falcor example is a very good example because this was a very good platform, and so SOI could achieve a very good ship. But this is because initially the ship was good, because when you want to make a refit with an old ship, so there is so many constraints, so the noise is very important. There is a stability of the ship. When you deploy the vehicle, you have some also to have some freeboard, not too much. You have the handling areas that must be positioned at the correct position and so on. So the design of a ship, it is not just only taking another ship and to put an A-frames. It's much more complicated than that, in fact.
At the same time, it seems like more could be done in the future to make ships or platforms, hulls, more usable by the research community, and probably will require some flexibility on the part of scientists as well. Victor, you've got?
How many of these are there? Yeah. Am I it?
Go ahead.
Oh, okay, sorry. My name is Jules Hummond, and I'm interested in addressing the question of turning the UNOLS fleet and the rest of the oceanographic research ships into a real-time telemetered global coverage of all data coming in from the ships back to land, everywhere else. It would be much nicer if the EEZs would go away. There's a very large collection of the ocean that can't be covered. I mean, this is a comment, not a question, because I don't know that anybody can do anything about that in the nearest time.
But can I comment on that?
Sure.
Not that we can do anything about it, but I've looked at this in another context. Another hat I wear of many, other than being the UNOLS chair, is one of the leads for this project that some of you may have heard about called Oceanscope. And it really is to integrate ships of opportunity all over the world and equip them and send the data back and do just basically what Jules said. And the idea is repeat transects. It's commercial vessels, no people on board, automated. And of course, the first working group we had in this were the Legal Eagle working group and the Law of the Sea people. Some of the people doing the prototype operations for this were getting marine science clearances specifically to get into the EEZs of other places. Other people in the world doing this have never been getting the clearances. There was a major push we dealt with in IOC about getting something defined about operational oceanography. And in the end, I think what we're coming to for this concept is something very similar to what the Argo has come to, and it's a lot easier in this case. With a research vessel or with one of our commercial ships running regular transects, we know the endpoints. So we know who to get the clearances from. If we can solve it for an Argo float, which might go wherever the hell it wants, except for a place where it's highly dynamic, where it's going to move away from to go to a quiescent area, then we can solve it for a ship. But it does take interacting with the endpoints.
Yeah, that's a good point. And I was going to mention the importance of the IOC in helping to sort some of these issues for not just ships, but for other instruments that might be out there. And kind of EEZs aren't going away, but we can perhaps do more as members of the global community to help reduce concern about certain kinds of instruments. In Indonesia, where I've done a lot of work, and Ambassador Hume can verify this, is deeply suspicious of instruments they don't understand. So a very important part of getting there is to socialize those instruments ahead of time. It doesn't always help, but I think there are things we can do as the global community to reduce some of the concerns in other countries' EEZs. But it's a long-term process. Next, please.
Hi. This is a short comment and then the question. My name is Jim Bishop. I'm a professor and undergraduate advisor at UC Berkeley. And basically, I want to talk about the value of coastal vessels in undergraduate education. So I in fact develop robotic systems, carbon explorers, carbon flux explorers designed to profile and measure carbon sedimentation autonomously absent of ships. But I really need coastal vessels to develop this method. And the great blessing of these short cruises is that you can actually fill them up with undergraduates. And so in the last 3 years, I've taken 26 individual undergraduates, including a running back for the Cal Bears, out to sea. And they've all had a blast, and they've totally increased the efficiency of the ship operations far above what we've been able to do with the funding that we had for the operations. So I just wanted to say, it's a huge value. It's hard to quantify right now in dollars and cents. But if we continue to lose these ships, and I know that this is just constant, this is going to be a major setback to education. And I totally disagree with the notion that undergraduates would prefer to watch a computer monitor rather than actually stand on the flying bridge and have wave spray splash in their face. So how do we turn this situation around and reach policymakers with that message?
Who wants to take it?
Well, sure, I totally agree with that, and this is something that really, you know, the academic research fleet it's a cornerstone of what we do is growing the next generation of ocean scientists, and I would say that this is an important part of our professional obligation to not just future scientists and growing the population of scientists, but you know, for all the people that are Cal running backs that probably aren't going to go on to be oceanographers, that's going to inform them later so that, you know, when they're watching the news 10 years down the line, you know, they understand a little bit about what's going out there, what's going on at sea. So when it comes time to you know, making policy decisions, they know how relevant this is to them. So I think it's critically important. Ways that I think are really important for sort of fostering undergraduate exposure are academic programs that are conducted, I think, throughout the UNOLS fleet, taking people to sea, and it constitutes a really important part of our outreach program.
Yeah, absolutely. Okay, I think Michael.
Yeah. So Stanford running backs build their own ships, actually, what I wanted to say was that 3.5 years ago, I spent 6 months researching this whole idea. My job is to find innovative ways to solve problems, and what I convinced myself of, but of course I'm not the august body of oceanographers, was that the ships were totally wrong. They're built like a university college to do all possible science in the field of oceanography, when in fact it's like people riding on a bus. They want to go to different places. They'd all be happier if they had their own taxi cab. And so what I would look for was the smallest ship that was safe, going 6,000 nautical miles, taking a full science team and equipment, robust in the ocean, up to 80 degrees north Svalbard, down in the Southern Ocean. And I got so involved in that you know, I found out that I could build those ships with 100 times better fuel efficiency than old style boats like a Lone Ranger or something like that. And so I started building them. There are 9 boats going now. They're not science boats. They're enjoyed by people who are forward thinking. But they turn out to be so special that they're being bought now. I'm in the, you know, work on this my side kind of job is building military boats for other nations. Because what they found out was that German and French and American military boat manufacturers have this staffing, manning idea that it takes, say, 40 people to run the boat, because it took that in World War II. And now you can do it with 8 people. So we do smaller engine, smaller boat, smaller everything. To get like the storage container to work on the boat, we have to make it set down almost into the keel to keep the center of gravity right, but we build the boat around that. So a lot of clever things we've done to build really world-class ocean-going boats that cost, like, they say $30 million. That for the price of one giant boat, like James Cook or Segarniti from Fincantieri, you could buy like 5 or 6 boats. And it's not like I'm trying to sell anybody boats. I'm just saying, if I can do it in my spare time, you could do it. You know what I mean? So it seems like we're asking the wrong question. And I've talked to a lot of scientists, and I said, these giant boats, do you really like going 40 to a party? Do you do 40, do all scientists work at the same time? And they say, no, those darn guys, I got to wait till, Thursday next month to do my job, So it seems totally wrong to me. And so I'm asking, I was waiting for you guys to say the whole modality is wrong. What we really want is a bunch of independent boats, give each student team and each professor their own thing in parallel and save money. I have like 40-meter boats that get like 2 gallons per nautical mile. It's a completely different game at 12 knots. So why aren't you guys building boats like that? Why aren't you asking for them? Why are you building 1940 boats? Please.
Okay. Peter is desperate to answer this question.
Well, no, I actually thought I did comment on that, but I'll do it again because I agree with you. There's a strong, as I mentioned earlier when I was saying that describing the shrinking of the fleet that was generally described and this tendency to get each of the classes have grown. And, well, it's designing by committee. You say you have a regional vessel, you ask everyone in the community what it needs to do, you end up with a giant list. The thing gets, as Marc described, fatter, shorter, and less fuel efficient. It's an automatic function. Those of us who are sailors like me said, well, we kind of like to be like long and skinny, and that there's a lot of advantages to that. And this has been discussion. There's an active, ongoing discussion in UNOLS precisely about that point, whether we need to be having, a certain number of, to do the jobs that need to be done, smaller, more fuel efficient, distributed vessels. But a countervailing point, and Dave brought this up, is there's a lot of, I don't know what the right term is, support infrastructure and costs associated with the vessel. And that maybe he wants to address this more, but it's not quite as simple as the actual fuel and people out there per vessel. There's a lot of factors that go into figuring out which is cheaper.
Right, and I agree with that concept and that approach. Given every university having 30 million, 20 million to construct a boat, they do also have to think about the operating costs. So in a fleet with finite resources, such as UNOLS or NOAA, you got to look at where you're getting your most capabilities for limited dollars. And typically, unfortunately, because you don't run government like a business as much as we want to and are constrained from doing that, it's, the construction pot is one piece of money, and then the O&M is another. And I think, so instead of building a $150 million ship, building 5 40-meter ships, then you've got 5 times the infrastructure potentially, and those 8 people are 40, where one ship it would be 20. So there's a little bit other calculus in there.
Great, thanks. We have time for one more question or two if Victor is kind. Okay, yeah.
I'd just like to quickly ask the panel their thoughts on instrumentation and the paradigm of all the scientists that bring all their own instruments to the ship and then fly them all off. I mean, talk about your carbon footprint then, versus having a basic suite of instruments that live on the ship maintained by the crew versus having instruments that live on the ship but are maintained by PIs that are on shore but can visit the ship. And so what do you think is the proper mix there, and what are we doing that right?
I don't know if we're doing it right, but what you've described is exactly what occurs, I think, in both the UNOLS fleet and the NOAA fleet, because I know when I was being the director of AOML, we had things out on the NOAA ships, that the PCO2 systems, as you well know, that were basically maintained by the people at AOML, and similarly on the UNOLS fleet, we've got exactly that mix. For example, the best example is we're sitting in the front row here. All the people coming out on the ship pretty much now require the ADCP, and they all look to the young lady here to make sure they're getting their data back properly. And similarly, so we're improving in that regard, but that's yet another area we have to look for every possible efficiency. You got to suppress the tendency that everybody has to be able to do everything. That can't be the best way of doing business. Some people can do the important jobs for a lot of other people and do it better than.
And then there's a question, if I could take just 1 second, of hybrid, where there's kind of a standard instrument suite that's on the ship, and then the possibility of this modularity playing out so that PIs can bring, or groups of PIs can bring specialized instruments. I don't know if there's a further comment on that, but that's a little bit the model we have with the Oceanography Explorer.
Yeah, I mean, that's an area ripe for some process improvements. I think there's efficiencies we can gain there, and we're probably running a hybrid model now, but it's again, does that instrument need to be used every time? Is it used on other ships? You just need to look at it and be smart about it, but ask the question. So.
Okay, Victor hasn't hauled us off the stage, so I think we have time for one more. Anybody?
So I guess I get the last question. It's going to be an unpopular one. Charlie Erickson from University of Washington. I'd like to get your reaction. I'd like to ask you, what is your reaction to the editorial in Nature about 5 weeks ago that said that NSF had spent all its money on lots of other things and didn't have money to replace the regional research vessels and should postpone them. Could you give me your reaction, please?
It's funny you should ask that. All I can tell you is keep posted, look in a subsequent issue of Nature for the response from UNOLS.
Thank you so much.
I can throw you a bone, he said.
Come on.
The heads up is we disagree, and we think that was an insufficient analysis of the problem. Yes, we don't disagree that the drill ship is an important asset, and part of the sets of observations we need to understand the planetary system, but the conclusion from that therefore you need to stop on the regionals would be extremely short-sighted, and for all kinds of reasons, given the pressing nature of the problems people in this room are being asked to solve for the benefit of the nation and the world.
And just one follow-on comment is that when you look at how long it takes to build a research vessel, I think in 1997 was the first planning meeting for the Ocean-class Agors, and the first one will be delivered to Woods Hole late in 2014. So that's an example of how long this process takes. RCRVs have been in the works for almost as long. So. And they've aborted that process once at great cost and lost time. So I think that to stop that process again would be foolish. We need to continue forward with that RCRV process.
One last comment. I would point out that even with the construction of those 3 vessels, our projections say, given the service lives in our fleet, even with the hoped for Navy extension on the globals, we're looking at half the capacity of sea days in the next decade and a half in the fleet, even including those vessels if they were all built as planned.
Okay, great. Well, my thanks to the panel. Really.
Thank you so much, David. Thank you, panelists. Our program today will continue with dinner at 5 o'clock and 30 minutes, and it's about 1 hour and 30 minutes, 1 hour 20 minutes from now, followed by the plenary presentation on the technology race to control the oceans by Dr. Jim Bellingham at 7 o'clock.
Just one quick point. Those of you need parking